Why did Einstein redefine Newton's gravity? Imagine trying to understand how planets orbit or why light bends around the sun. For centuries, Newton's ideas helped us explain these things with simple rules. Newton said gravity was a force pulling objects toward each other, like an invisible hand. This idea worked well for most everyday situations and even for predicting the motion of planets. It became the foundation of science, engineering, and space exploration. But as scientists looked closer, they noticed some strange things that didn't fit Newton's model. Mercury's orbit showed tiny deviations that Newton's laws couldn't explain. During a solar eclipse, scientists saw light bending more than Newton predicted. These small differences made scientists think that maybe Newton's idea of gravity was not the full story. Albert Einstein wanted to find a better explanation. He thought that gravity might not be a force at all but something different. He proposed that space and time are connected in a four-dimensional fabric called spacetime. When a massive object like the sun sits in spacetime, it causes a curve or warp. Think of it like a heavy ball on a trampoline making a dip. Smaller objects, like planets or light beams, follow the shortest path along these curves. So instead of being pulled by a force, they are simply moving along the natural curves in spacetime. This idea explained why Mercury's orbit shifts and why light bends more near the sun. Another reason Einstein redefined gravity was to fix the problem of action at a distance. Newton's gravity seemed to act instantly across space, which didn't sit well with the idea that nothing can travel faster than light. Einstein showed that changes in gravity also travel at the speed of light, just like light itself. This means if the sun suddenly disappeared, Earth would not feel the change immediately but after a delay, traveling at the speed of light. This idea made the universe more consistent and aligned with what we know about how things move and communicate in space. For practical uses, Newton's laws still work well for most engineering and everyday calculations. They are simple and fast to use. But when scientists need extreme precision, like in GPS satellites, Einstein's theory becomes essential. GPS signals travel through Earth's curved spacetime, and without Einstein's corrections, your phone's location could be off by hundreds of meters. In essence, Einstein redefined gravity because Newton's model couldn't explain certain observations and because it didn't fit with the idea that nothing can go faster than light. Einstein's approach showed that gravity is not a force pulling objects but the result of objects following the natural curves in the fabric of spacetime. This shift gave us a more complete picture of how the universe works and allowed us to develop technologies that depend on understanding these tiny but important effects.